Hello grade 12, Mr. G here, and we're going to make another video. In this time we're going to make videos about elimination reaction. The first one we're going to look at is cracking. It's quite easy, so the video is going to be real short. So what is going to be cracking? That is going to be when you take longer alkane chain that can be broken up into shorter carbon chains. So you're going to take longer alkanes and you will break them into small pieces. Those pieces can either be shorter alkanes plus alkenes, as it is here in the first option. We have alkanes that obviously going to be longer alkanes, and we're going to cut them into smaller parts. Those smaller parts can either be shorter alkanes plus alkenes, or it can also be shorter alkenes plus hydrogen. So this is the cracking general equation. You're going to have alkanes most definitely in the reactants, and you're going to end up with shorter alkanes plus alkenes or shorter alkenes plus H2 or hydrogen. Now, what are the conditions for this type of reaction? Now, be careful. There are two types of cracking. Cracking could either be thermal cracking in which high pressure and temperature without a catalyst is needed for this one to happen, or cracking could be catalytic cracking. So we have two types of cracking: thermal cracking and catalytic cracking. Okay, now the catalytic cracking will be at lower temperature with a catalyst, example PT or platinum. Okay, so conditions, we have two different types of cracking: thermal cracking, which is done at high pressure and temperature without a catalyst, or catalytic cracking, which is done at lower temperature with a catalyst. Now, let's see one example. We have this one here is the same one. I write two I's because we have two options. This one could be broken in two different ways. So the first one, we can separate it in two carbons and two carbons. Now, if we make the first one a shorter alkane, for example, and we complete all the hydrogens here, this one is a shorter alkane, we have 6 hydrogens. Now we have left 2. This is 3, 6, 4. We have 4 hydrogen left. So if we give one hydrogen here, another one here, and here, this one must be a double bond. So you can see in this reaction, you have, first of all, a shorter alkane. We're starting with 4 carbon in straight chain, and then we end up with one alkane of 2 carbon plus an alkene of also 2 carbon. So we broke this alkane into a shorter alkane plus an alkene. That is the first option, and this one you can see is a catalytic thermal cracking. So, pardon, a catalytic cracking. The second one, we have the 4 carbon, but now we are going to make an alkene. We're going to take hydrogen away, 2 hydrogens, sorry. We're going to take 2 hydrogens away, H2, and we have still 4 carbon, 1, 2, 3, and 4, but minus 2 hydrogen. So the 2 hydrogen will be gone from the middle one. Remember the rule of taking away the carbon from the hydrogen from the carbon that have less hydrogen. So the double bond will be there, and then the rest will be hydrogens. So this one is the catalytic cracking of butane. Here we have the other option. So this one is broken into H2 and a alkene. Okay, so I hope this one is understood. It's not that difficult. It's very easy, and it may be a question. Note the following: if you starting with an alkane with 4 carbon, at the end, when you add all the products must also be 4 carbon. You cannot have more. You cannot create atoms or eliminate atoms. Okay, they just get redistributed. Okay, so thank you for watching. This one is about a cracking. It's quite short, it's very easy, and it's quite important. It might be in the exam. Thanks a lot, and good luck.